In this lecture, we look further at the slope and introduce the average rate of change. We continue to study the slope of a line, working through several examples. Let's find the equation for the line passing through the points 3, 8, and 620. And we're going to put our answer in point-slope form. Here's the solution. First, we find the slope of the line passing through the points 3, 8, and 620. That's the rise over the run. The rise in this case is 20 minus 8, and the run is 6 minus 3, so we have 12 over 3, or 4. So that's the slope of our line. If the line goes through 620 and has slope 4, and goes through some other line, x, y, then our slope is 4, which is the rise, y minus 20, over the run, x minus 6. Multiplying through by the denominator gives us that 4 times the quantity x minus 6 is y minus 20. There's a fine answer. A related problem. Let's find the x-intercept of the line passing through the points 3, 8, and 620. From a previous problem, on the previous slide, we discovered that the equation for our line was 4 times x minus 6 is y minus 20. So setting y equal to 0 in the solution from the previous problem gives us this. 4 times x minus 6 is 0 minus 20. Divide both sides by 4. Simplify on the right side. Add 6 to both sides, and x is 1. So what is the y-intercept? It's the point 1, 0. Another problem. Suppose the line y equals f of x has slope 4 and passes through the point some big messy number for x, some big messy number for y. Find f of 12,402. Let's keep this as simple as possible. The messy numbers are in fact intended to prevent us from doing much computation. A line of slope 4 has the property that every step to the right creates a rise of 4. Now we're told that when x is 12,400, then y is 999,900, and we're asked for the y value at 12,402. 12,402 is 2 steps to the right from 12,400. And if we take 2 steps to the right on a line of slope 4, we must rise 2 times 4, or 8. So if we began with y value of 999,900, we must end at a y value of 999,900 plus 8. So there's our answer. The y value is 999,908. Notice that we did not need to deal with any equations. Merely understanding the meaning of slope was enough to quickly do this problem. We noticed that the x value we're being asked about was 2 steps to the right of the old one, so we knew that we had to rise by 8, since slope was 4. Suppose the graph of a function is a straight line of slope 12, and someone told you that f of gazillion was Google, and then asked you for f of gazillion plus 3. Gazillion is not a real number. It's made up, but let's do this problem anyway. If f of gazillion is a Google, and then I move 3 to the right on a line of slope 12, I must rise by 36. So it must be at a Google plus 36. So there's the answer. That's it. Easy. Piece of cake. Suppose 2 points P and Q are on the graph y equals f of x of a function. Since f is a function, then by the vertical line test, these 2 points cannot have the same x value. So let's concentrate on the point P on the graph of this function and write its coordinates as x comma f of x. The other point Q has x-coordinate x plus some value h. In other words, h is going to be the run between the points P and Q. The point P has x value x. The point Q has x value x plus h. So the coordinates of Q are x value is x plus h, and the y value is simply f of x plus h. The slope of the line joining P to Q is the ratio of the rise to the run, change in y over change in x. The change in y is f of x plus y minus f of x, that's the y value of Q minus the y value of P, over x plus h minus x, that's the x value of Q minus the x value of P. The denominator simplifies to h. The numerator does not simplify. So we have this formula. That expression, f of x plus h minus f of x all over h, is sometimes called the difference quotient. It's the slope of the line connecting this point P to that point Q. It is also called the average rate of change, or ARC, of the function f of x between those 2 points. The average rate of change of the function f of x from x to x plus h is the slope between the points P and Q. And the slope of the line joining P to Q is simply, by our understanding of slope, the change of y over x. So it's this formula which simplifies to that. The average rate of change is a critical concept in calculus. Let's do an example or two. Let's consider the quadratic function f of x is x squared and find the difference quotient for this function. So we compute that fraction, f of x plus h minus f of x over h. It's a slope. In this problem, f of x is x squared. So f of x plus h is the quantity x plus h all squared. And f of x is just x squared. So using our function f of x, we substitute in and get this fraction. Simplify the numerator by expanding out x plus h, the quantity squared. Cancel out the x squares, so the numerator is 2xh plus h squared. And now notice that everything on the top and bottom is divisible by h, so it simplifies to 2x plus h. So there is the average rate of change, the general average rate of change for the function f of x is x squared. We could do an example with the particular points. So let's find the average rate of change of the same function, but let x vary from x is the number 2 to x is the number 5. The average rate of change, again, is just the slope of a line. Here, we want the slope of the line through 2f of 2 and 5f of 5. In this case, because my function is f of x is x squared, then f of 2 is 4, and f of 5 is 25, so we want the slope between 2, 4 and 5, 25. And we can do that. Let's rise over run. Simplify it. 21 divided by 3 is 7. In the next presentation, we will explore quadratic functions.